Welcome to Maths with EJD. In this video, I'll take some questions on metric spaces. Two parts. The question is in two parts actually. So, and the first one is this: that let xi, pi, and all that starting from I equals 1 to infinity be a sequence of metric spaces. Be a sequence of metric spaces. Be a sequence of metric spaces. Then let x, which is equal to, okay, that's capital pi, right? Something like this. Pi. I hope I got that right. Equals pi. X equals pi from I equals 1 to infinity. It's pi. Be the product. Be the product of this metric spaces of this the product of this metric spaces then define p prime to be that pi now. Okay, something like this pi now, to be that pi from I equals 1 to infinity of xi times, same thing again, again that's one, I equals 1 to infinity of xi again, of xi, like that. Okay, and that is mapped to the real number system, like that. That is that p prime of x comma y is equal to the summation let's see, that is p prime, okay, yeah, p prime, okay, that is p prime is x times x, like this, x times x mapped to a real number system. Okay, yeah, to the real number system now, defined by p prime of x comma y, which is the summation from I equals 1 to infinity of 1 over 2i, and then you have pi of x comma yi all over 1 plus pi into x comma yi again. So the question is to show that p prime is a metric on x. Okay, so I try to go over that again to be sure everything is in order. So let xi pi from I equals 1 to infinity be a sequence of metric spaces, and let x equals that pi I equals 1 to infinity be the product of this matrix. Then define p prime to be this the summation of all the xi's from I equals 1 to infinity multiplied by xi from I equals 1 to infinity mapped to the real number system, that is p prime is such that you have x times x mapped to the real number system defined by p prime of xy equals the summation from I equals 1 to infinity of 1 over 2i pi into x yi all over 1 plus pi into x comma yi. We have to show that p prime is a metric on x, all right? I want to show that p prime is a metric on x. Of course, it's important to note that to show that something is a metric, there are 4 tests. So 4 properties that you have to check. The first one is non-negativity. Non-negativity. That simply implies that that the metric, right, that p prime of x comma y is always greater than or equal to 0 for all x and y, in the real number system. That's one. The second one is the identity of indiscernibles. Identity of indiscernibles. Indiscernibles. So that means that here p prime of x comma y, okay, let me be yi this time, right? It's greater than or equal, is equal to 0, sorry, is equal to 0. Yi here is equal to 0 if and only if x is equal to y. Okay. And the third thing that helps us to know if something is a metric is the idea of symmetry. And in this case, that would mean that p prime of x comma yi is the same thing as p prime of y comma xi, for all x comma y in the real number space, like that. And lastly, you have the idea of triangle inequality. Triangle inequality. And that is when you say p prime of x comma zi is the same thing as p prime of x comma yi. I mean, this is less than or equal to, not equal to, less than or equal to p prime x comma yi plus p prime y comma zi. So if you can prove these 3 for that metric, then it means that it is actually a metric. That is the idea. Okay, so let's go and take these things one after the other. So again, what we have is p prime of x comma y is the summation from I equals 1 to infinity of 1 over 2i, multiplied by pi into x comma yi all over 1 plus pi into x comma yi again, like that. So the first thing is non-negativity. So let's say for non-negativity or non-negativity, okay. So since each term in the sum, in the sum is non-negative, that is, you already know that p prime of x comma yi is greater than or equal to 0. It's non-negative because it's a metric, right? And same for when you add 1 to it, it even makes it more positive, so to speak. So you have pi x comma yi, it's also non-negative, all right? Since that is guaranteed, right, what do you say? So we can say that p prime of x comma y is greater than or equal to 0. So that has passed the non-negativity test automatically. Then we talk about the identity of indiscernibles, right? So number 2, for the identity of indiscernibles, for the identity of indiscernibles, what that says is that p prime of x comma y is equal to 0 if and only if x is equal to y. That means you prove it from this place to this place, and you also take it back from x equals y to that. So I mean, uh, from what we can already observe, right? So if we take it that if we take this first one, that p prime of xy, which is the same thing as the summation from I equals 1 to infinity of 1 over 2i, then pi into x comma yi all over 1 plus pi into x comma yi is equal to 0. If we take it this way, automatically, what this simply means is that, for this to be correct, to be 0, right, it means we are simply saying that, you know, uh, 1 over 2i pi into x comma yi all over 1 plus pi into x comma yi is equal to 0. That's what that simply means, right? And if you cross multiply, right, you end up getting pi into x comma yi. Okay? And if you now say that, of course, this is 0 now. So this simply means that you have the absolute value of x minus yi is equal to 0. Okay? So, of course, for every, since we have said it that x, for this to happen, right, it means that x minus yi is equal to 0. So that means for any y you have, x is equal to yi. And in essence, it means x is equal to y. So that's settled. Then you have to prove it in the reverse. So this is, so, here we started from this and we ended up here. So what if you take it in the reverse? So that means you have, okay, we started with this, if p of x y is equal to 0. So it means you just also do it in the reverse. And you now say if x is equal to y, then you just walk it back. So you just go back the steps. If x equals y, and it means you can say that x is equal to yi. And if x is equal to yi, that means that x minus yi equals 0. And that means that absolute value of x minus yi equals 0. And if that is the case, that simply means that p of x comma yi is equal to 0. If you like, what if you now divide it by something equally positive, p of x comma yi all over 1 plus p of x comma yi. If you divide both sides by that, you still get your 0, right? You multiply both sides by 1 over 2i. 1 over 2i p of x comma yi all over 1 plus p of x comma yi. Of course, still your 0. Then you can now take it back. You have a summation from I equals 1 to infinity, 1 over 2i p into x comma yi all over 1 plus p x comma yi. And that is 0, right? So finally, you can just, this is p prime of x comma yi, and that is 0. So it means you have, so if you start from x equals y, you can take it, you can prove it in both directions, right? That's what this is about. So with this now, we can say that p prime of x comma y is equal to 0 if and only if x is equal to y. So that's what we expected to do here. So that's the second thing we're proving. Then the next we talk about symmetry, right? Symmetry. So the third thing is symmetry. So I say that 3 for symmetry, symmetry, for symmetry, what do we have? We say that p prime of x comma y, is already given a summation from I equals 1 to infinity of 1 over 2i pi x comma yi all over 1 plus pi x comma yi, right? So, that's the same thing as summation from I equals 1 to infinity of 1 over 2i. P over pi is like absolute value of x minus yi all over uh 1 plus pi. Okay, same thing, x minus yi. So at the end of the day, you can actually do some smart moves. So you have 1 over 2i. Here now you can say this is, if you factorize minus, so that's like minus into minus x plus yi. If you factorize minus, that's what you get. And then over 1 plus, again, factorize minus down here. So minus x plus yi. So that if you expand this, you still get your minus, right? So that means this is the same thing as summation from I equals 1 to infinity of 1 over 2i. And then absolute value of minus into yi minus x, okay? Minus x all over 1 plus minus yi minus x again. And then, because we are taking the absolute value, right? So the minus doesn't matter. We have summation from I equals 1 to infinity 1 over 2i. And then that's so the absolute value of this is like absolute value of yi minus x all over 1 plus absolute value of yi minus x. So at the end of the day now, we can actually say, we started with x p prime x y, right? That's the definition we had from the very beginning. So p prime x y. So, and here now we can actually say this is summation from I equals 1 to infinity of 1 over 2i into p of y prime comma yi comma x over 1 plus p of yi comma x. So at the end of the day now, it looks like we have been able to tidy that up to have y coming first, such that that expression we started with has ended up with y coming first. So in that case now, we can now say this is simply the same thing as p of p prime of y comma x. So you started with x comma y, so now you have ended with y comma x. So symmetry check. So you can now say therefore p prime of x comma y is the same thing as p prime of y comma x. So that's settled. So the last thing is the triangle inequality. For triangle inequality, the triangle inequality. So here you have, so you can consider, so of course that's simply starting with p prime of x z. Okay, so we already know that, of course, we have p. Okay, let's start with p prime of x z already. P prime of x comma z, and that is summation from I equals 1 to infinity 1 over 2i pi into x comma zi all over 1 plus pi into x comma zi, like that. Okay, so if you try to expand all this, right? Okay, there's an approach we can actually use, right? P. So you know already this is this, of course, and we are told to, we are expected to prove that this is less than or equal to p prime x yi plus p prime y zi. That's all we are going to. So in this case, what do? We can start with, that p of xy is equal to the absolute value of x minus y. Okay, p of yz, you also know that's the absolute value of y minus z. So if we start with that, right, we start with the absolute value of x minus y plus y minus z. It does the same thing as the absolute value of x minus y plus the absolute value of y minus z. So here, of course, you can say this cancels out, right? So you have absolute value of x minus z here equals absolute value of x minus y plus y minus z. So you see that this is actually p of xz, and that is equal to p of xy plus p of yz. Well, we are just on a journey. So if you, okay, of course, okay, I guess what I did not do. Okay, yeah, like that, we're going. So the next thing now, so if we divide through, right, by the corresponding values down, so if we now say this to be x comma zi all over 1 plus p comma x zi, so that's pi now. If you take it to that realm, and then we have pi x yi all over 1 plus pi x yi like this, plus pi y comma zi all over 1 plus pi x comma zi that way. I mean y comma zi. Okay, so I think, in fact, from here, right, from even from the very beginning here, from all these parts, right, from right here, so this one can be given to be less than or equal to, I mean, from the rule of inequality, so this holds true, then like this, and then, so even if we take the summation of each side, we have summation from I equals 1 to infinity of pi x comma zi all over, okay, before we even put the summation, right, we want to put all the two i's. Okay, so you have 1 over 2i pi x zi 1 plus pi x zi less than or equal to 1 over 2i pi x yi all over 1 plus pi x yi plus pi y zi all over 1 plus, okay, of course, 1 over 2i now, then p I y zi. So you can put the summations, right? So finally you have summation from I equals 1 to infinity of 1 over 2i pi x zi all over 1 plus pi x zi less than or equal to summation from I equals 1 to infinity 1 over 2i pi x yi all over 1 plus pi x yi plus summation from I equals 1 to infinity 1 over 2i pi into y zi all over 1 plus pi into y zi. Well, it's actually very lengthy and can be boring, right? But I mean, just have to keep going. So now this is like p prime of xz, less than or equal to p prime x y I mean zi x y I plus p prime y zi. And then that way you can now say, therefore, p prime of xy is a metric on x. I think that's what the question is about. So we have been able to prove that it is a metric, that p prime is a metric on x. That's really very lengthy. So let's go to the next question. The next question is this. So let X, which is C into A comma B, like, is it something like in the complex domain? And then we have that P of X comma Y is the integral from A to B of the absolute value of X minus T, Y minus T dt. Okay, we have that. So simply prove. We want to prove what we have always proven. Prove that P is a metric. Prove that P is a metric on C, A comma B. So same thing, the same four proofs, the same four conditions of non-negativity, identity of discernibles, symmetry, and of course, triangle inequality. So here, I'll probably not take too much time. I'll just go straight to the point, one after the other. So of course, so we start with non-negativity. So for non-negativity, one thing is P of X, Y is greater than or equal to 0 because you can be sure that the integral of the absolute value of x of t minus y of t will be positive, right? Because the absolute value of x of t minus y of t by its own nature is greater than or equal to 0 because the absolute value guarantees that whatever you get is at the end of the day positive. So, I mean, this is a very simple way to say this. So in this case, so you see that this is guaranteed to be greater than or equal to 0. So the metric itself is automatically greater than or equal to 0. So that's easy peasy. And then we go for the next one for identity of discernibles, right? Identity of discernibles. And what that simply says is that P of xy, P of xy is equal to 0 if and only if x is equal to y. So it means you prove it forward, you prove it backwards. So if we take it that, so if you start from the other side, that if P of xy is equal to 0, what that simply means is that expression, integral from a to b of the absolute value of x of t minus y of t dt, if we take this to be 0, what this simply means is that the very core here is actually 0, So that means absolute value of x of t minus y of t is equal to 0. That's what that simply means. And that means x of t minus y of t is equal to 0. That means x of t is equal to y of t. And that simply means that x is equal to y. So starting from here, you have come to this point. So it's easy to go back, just follow the same path, just trace it back, So you now say if x is equal to y, just go back tracing. So it means that x of t is equal to y of t. That means that this also implies that x of t minus y of t is equal to 0. And then you can keep going and say the absolute value of x of t minus y of t is equal to 0. And then, of course, if you now do the include integral and all that, it's still the same. So integral from a to b of that x of t minus y of t dt is still 0. So at the end of the day, this expression now is back where we started from. So this is like p of x comma y is equal to 0. So you can say, therefore, p of xy is equal to 0 if and only if x is equal to y. So the if and only if is why we have to prove it both ways. Extremely important. Okay, so that goes. So we move on to the third one, talking about symmetry. So 3, is that the numbering I've chosen? Yeah. P at 3, that is For symmetry now, for symmetry, let's start with p of x comma y, which is integral from a to b of x of t minus y of t dt. Okay, you know, we can rewrite this now. So we can rewrite this. You know, the normal skill I like to use is factorize minus here. So I have absolute value of minus. So I have minus x of t plus y of t. So if you take minus out, like, right, it changes the sign inside. So dt like this. So I have integral from a to b of minus y of t minus x of t minus x of t dt. And absolute value means that the minus doesn't matter. You know, absolute value means the sign minus here does not really matter. So we can say that is integral from a to b of the absolute value of y of t minus x of t dt. So that at the end of the day, this is simply the same thing as p of y comma x. So you see now that our symmetry is guaranteed. So you can say, therefore, p of xy is the same thing as p of yx for all x and y in x, right? Like, is that what we have in the real number system? Okay, where's that now? Okay. Okay, not real number system, right? That's not x here. So very important. In C, A, comma B. So yeah, that's where we have this. So whatever space you're given, that's what you should use. Okay, so we've done 3. So we have the last one to go, which is triangle inequality. Triangle inequality. So here now we have yeah, we can apply the same thing we have been doing. So for 4 now, you can say for triangle inequality, for triangle inequality, for triangle inequality, what happens is that we can say that you know, let's even start with, we know the absolute value of x of t minus y of t plus y of t minus z of t, like that, right? It's the same thing. It's less than or equal to the absolute value of x of t minus y of t plus the absolute value of y of t minus z of t. So that way, so of course, you know, this cancels out. So we have absolute value of x of t minus z of t, like that. And that is less than or equal to the absolute value of x of t minus y of t plus y of t minus z of t. So you can now include every other thing that's not there. So you have integral from a to b of absolute value of x of t minus z of t dt, you know, less than or equal to integral from a to b of x of t minus y of t dt plus integral from a to b of y of t minus z of t dt. So at the end of the day, you know, they look like where you're coming from already. So this side now is just your p of x comma z. You know, the original definition is what again? Yeah, p of xy. So that is p of x z is less than or equal to p of xy plus p of y z. So on this note, you can say therefore p of xy is a metric on this given space. Is a metric on C, A, comma B. So on that note, we've come to the end of this whole thing that looks a bit boring, but that's how to go about it. So if you have not signed up to this channel, please be sure to do that. Hit the notification bell so you can always get notified whenever I have a new video released. Like, comment, and of course share, because a lot of people would really find this very useful. Thank you so much for always listening. See you in the next video.